Deep space offers zero margin for error. Outside a spacecraft's hull, there is no air. The soil is steeped in toxic chemicals, and cosmic radiation can degrade human DNA within days. Keeping a crew alive across a 200 million-mile journey requires every life support system and sensor to operate without a single failure for years at a time. While the Carver-Lacks Horizon appears to be a leap forward, its systems are actually a specialized archive, built on the biological and technological insights of Black creators across centuries. This genetic map shows the maternal lineage of every living person. By tracking mitochondrial mutations, geneticists found that the family tree of all 8 billion humans converges on a single woman in the East African Rift Valley 200,000 years ago. The crew carries this original biological signature into the void. To survive the Martian frontier, they must rely on the specific resilience and blueprints of the past that emerged from our African origins. Inside the ship, cosmic radiation is a constant, invisible threat. The crew needs a detection system that reacts to cellular stress faster than mechanical instruments. In 1951, a tumor sample was taken from Henrietta Lacks. While normal human cells stopped dividing after a set limit, hers multiplied continuously. They became the HeLa line, the first immortal human cells ever grown in a laboratory. When researchers sent these cells into space in 1960, they discovered that HeLa cells don't just survive in microgravity, they replicate faster and show higher resilience than they do on Earth. On the horizon, these cells are housed in specialized chambers where their growth rate is monitored by AI. They serve as a biological early warning system, signaling radiation spikes before they can affect the crew.
Maintaining a pressurized, breathable environment is the primary challenge of deep space architecture. A single leak or a failure in the airlock would be catastrophic. In 1912, Garrett Morgan invented the safety hood. It used a tube that reached the floor to draw in cooler air, a moist sponge to filter out toxic smoke, and an exhaust valve to carry carbon dioxide away from the wearer's face. This exact engineering, filtering out contaminants while recycling oxygen and venting waste, is the foundation of the portable life support system backpacks that allow astronauts to breathe during spacewalks. To prevent accidental depressurization, the ship uses a mechanism patented by Alexander Miles in 1887. He designed the first automatic elevator doors, a system that ensures hatches seal themselves without requiring human intervention. The crew can move through a vacuum because they are using systems originally designed by Black inventors to solve the hazards of earthbound fires and industrial accidents. The garden deck is the ship's internal ecosystem, but Martian regolith is essentially toxic crushed rock. It contains perchlorates and lacks the organic nitrogen needed for plant life. In the late 19th century, George Washington Carver solved a similar problem in the American South. He taught farmers to plant peanuts and other legumes because they host bacteria that pull nitrogen from the air and fix it into depleted soil, restoring its fertility. The horizon replicates this cycle. By rotating peanuts and sweet potatoes in the regolith, the crew uses the Carver method to pull nitrogen from the cabin air and build a layer of living, dark earth across successive growing seasons. This closed-loop agricultural system turns the waste of the cabin into the nutrients of the soil, providing the framework for sustaining life on an alien world. Hitting a landing site on a planet millions of miles away requires a margin of error measured in meters. If the navigation math is off by a fraction of a percent, the lander misses Mars entirely. This precision was established at NASA by Katherine Johnson, who hand-calculated the trajectories for the first human spaceflights, and Mary Jackson, who analyzed the aerodynamic forces on spacecraft heat shields. Dorothy Vaughan then translated these complex physics into the first automated computer code. The digital navigation systems directing the horizon today are the automated execution of the mathematical frameworks these women drew by hand. Descent is defined by the 7 minutes of terror. The lander hits the thin Martian atmosphere at 12,000 miles per hour, generating 3,000 degrees of heat against the shield. The landing is the culmination of the legacy of the 25. Mary Jackson's aerodynamics stabilize the descent, while Dorothy Vaughan's code executes the retro-rocket burn to slow the craft to a hover. The airlock opens. Commander Victor Glover takes the first human step onto the Martian surface. He is protected by Garrett Morgan's filtration logic and wearing layers stitched with the precision of master garment workers. He carries the same seeds Carver used to restore the soil of the South. He plants a flag that lists the names of the ancestors: Banneker, Latimer, Johnson, and Lacks. Their genius is the silent passenger on this mission. This arrival is not a departure from our history, but a continuation of it. The ingenuity required to thrive on Earth is the same brilliance taking humanity to the